Hello to everybody, I'm Stefano Faralli, I'm assistant professor in Scuola Superiore Sant'Anna, sharing my poster. Okay, the title is Fast FBG Sensor Interrogation Method based on silicon microring resonator. And in this poster, we present a fast FBG sensor interrogation method based on silicon isolated microring resonators that improves the solution proposed previously using integrated photonics. The commercial FBG interrogator are mainly based on interrogator based on diffractive filter and CCD array, so interrogator based on tunable laser sweep. But fast events are hardly to be identified by the commercial interrogator. Silicon photonics promises the fabrication of low size, low weight, low power and low cost FBG interrogator by CMOS compatible process with a full integration of photonic and electronic integrated circuits. So silicon and isolator-based technology can lead to a full penetration of the FBG sensor into the sensor market. In our technique is based on the detection of signal intensity at the drop port of the ring resonator. In particular, the FBG reflected peak is coupled at the input port of a microring resonator. The reflected signal intensity is detected at the drop port of the ring resonator, and the resonance wavelength of the ring resonator is tuned initially and kept fixed at a given wavelength. So the optical intensity variation measured at the drop port correspond to the wavelength shift, and so the events that can be detected, the frequency speed of the events that can be detected depends only on the electronic and photodiode speed. So in the picture at the top on the right, you can see the microscopy picture of the ring resonator that has a ring radius of 10 microns and the mask layout of the fabricated silicon photonic integrated circuits. The poster reports the dynamic characterization of the FBG interrogator and the comparisons with a commercial interrogator. So applying a strain periodic variation of 400 Hz, we measured the wavelength shift using the microring resonator and the commercial interrogator. And as you can see in the figure, so the wavelength shift versus time and the corresponding spectra of the measured wavelength variation signal at 400 Hz, the microring resonator based interrogator improves the performance of the commercial interrogator. So the experimental comparison with the commercial interrogator has been carried out through static and dynamic strain tests, showing a good agreement and validating the proposed FBG interrogation method based on microring resonator. Thank you to everybody.